Filling in the pieces. Each problem below involves an unknown angle theta given in radians. You are given the value of one of the trig functions at theta along with what quadrant theta is in. Use this information to find the values of the other 5 trig functions. You should not use any trig keys on your calculator to do this. In fact, you will get the most out of this activity if you use your calculator as little as possible. Answers follow. Number 1, theta is located in the first quadrant between 0 and pi over 2, and sine of theta is 3/5. So I've gone ahead and copied and pasted my blank things over here so that I don't have to spend time in the video doing that. So just as we did at the end of the last class's video, there are 2 ways to tackle each of these problems in the activity. You can either draw a picture and use Pythagorean theorem, or you can just do algebra and use one of the Pythagorean identities. I prefer doing the algebra. If you prefer the picture, then draw some pictures. But we should get the same answer at the end either way. So because this problem involves sine, I know I'm going to use the trig identity that involves sine. So that identity is sine squared theta plus cosine squared theta equals 1. So sine of theta is given as 3/5, but we know that sine squared theta really means take sine of theta and square it, plus cosine squared theta, which we're trying to find, that equals 1. Square this fraction, we get 9/25. Plus cosine squared theta is 1. Subtract 9/25 from both sides, make a common denominator, and what do we get? 16/25. And then take the square root of both sides, but then don't make that mistake that I made in the video. So this one reduces, most of them don't, but this one reduces. And the mistake I made is to forget that at the moment you take the square root of both sides of an equation, you need to put in plus or minus. So plus or minus 4/5 is our answer. Well, you got to pick one. You got to pick the right one. So how do we know which one to pick? Well, that's where this quadrant stuff comes in. So imagine you're in the first quadrant. We know that cosine is always, just in terms of x, y, and r, we know cosine is x divided by r. So the r part is always positive. We just always treat the r as being positive. So the real question is x positive or negative in the first quadrant? So pick your favorite point in the first quadrant and plot it, and ask yourself if the x coordinate is positive or negative, and hopefully you see it's positive. So that's it. That decides it for us. Out of the plus or minus, it should have been plus. So cosine of theta is 4/5, positive 4/5. Sine of theta was given, we'll just fill it in, it's 3/5. Tangent of theta, let's see, we know that tan theta is the y divided by the x, y divided by the x. Let's see, the x turned out to be 4, we just found that, so we'll fill in the 4 at the bottom. What was the y? Well, the y is given up here because we know that sine theta is always y divided by r. So apparently, y was 3. So the y is 3. And we just get 3/4. That's our answer here. If you don't like that way of finding tangent of theta, there is an alternate that you can follow. Or tangent of theta is. So we know the tangent is many things, but one of the things tangent is sine over cosine. And the cosine sine of theta was given, it's 3/5 in this problem. And the cosine of theta we worked to get, that's 4/5. And then all you have to do is clean up that fraction. The 5's cancel, and we get 3/4, same as we did before. And then with that out of the way, since we've lined things up nicely, we know we just need to take reciprocals. Okay, moving on to number 2. Theta is located in the third quadrant. I'm ignoring that information for right now. Secant theta is -2. Okay, I'm going to use one of my favorite Pythagorean identities, and it's going to be the one with secant in it. So what does that identity say? It says 1 plus tan squared theta is secant squared theta. So let's plug into this. 1 plus tan, I don't know. Apparently we're going to find that. Equals secant squared. Secant was -2. -2 is getting squared, including that negative sign. So it's going to turn out to be +4. Subtract 1 from both sides. Take the square root of both sides. We'll forget the plus or minus. We can't simplify that anymore. Although if you're really on the ball, you might recognize that theta is actually one of the nice angles on our unit circle because tangent of a nice angle happens to be radical 3. But that's neither here nor there. We do have to figure out if it's the plus or minus. So we are in the third quadrant. And down there in the third quadrant, thinking about the tangent of an angle. So if we just have some random old angle here, and we pick our favorite point, and this is an x and a y, and we know that tangent of our angle is y divided by x, among other things. What can we say about the signs of x and y here in the third quadrant? Well, we went left, so x must be a negative number, and we went down, so y must be a negative number. So these are both negative numbers, but when you divide two negative numbers, you get something positive. So the whole thing must be positive. So tangent of theta must be positive root 3. Okay, let's keep filling in. Secant of theta is given to us as negative 2. All right, so we better find one more thing. So how do we find one more thing here? Well, I mean, I guess we could do the easy parts right now, right? Cotangent is a reciprocal, 1 over root 3, right? Because this is over 1, so put that in if you need to. Secant is also a reciprocal. So cosine gets a negative 1/2. All right, sine and cosecant, how are we supposed to find? Either one would be fine, right? We just need one and then we can get the other. Okay, let's see. So sine of theta is the unknown, and we know cosine and we know tangent. So let's go back to basics. We know sine of theta is y divided by r. Okay, well, we also know that cosine is x divided by r. So apparently that means that the x value, what are we looking at here? The r value that we found was 2. Okay, that's good to know. So it must be a 2 down there. And we need to know the y value. So do we have the y value here any place? Well, let's think back to our definition up here at the top. Tan theta is y over x. Well, we've already figured out that tan theta is root 3. So if I force that to be a fraction, it's root 3 over 1. Okay, so I guess that means that the y was root 3 and the x was 1. So is that helpful? Oh, good. The y apparently was root 3. So upstairs here, we get to put root 3. Not negative, but positive, just copying it as we see it. So root 3 over 2. And that's the sine value. And then cosecant, just flip it over. Okay, but I made a little mistake here, and when I forgot to put in the plus or minus in the class video, that was a mistake that was on purpose, but this mistake I just made was not on purpose. So sine of theta is actually negative root 3 over 2, and the place that I made my mistake was that I forgot that the x and the y that we figured out, they were both negative. We decided that we're left and we're down. So the x and the y down here in the third quadrant are both negative. So, okay, so I can see that the x is negative, it's negative 1, but I didn't put in a negative y. I just assumed that, oh, y was root 3 and x was 1, but really x was negative 1, which means y must have been negative root 3. I was a bad detective. So we'll put that negative in there. Sine of theta is therefore negative root 3 over 2, and the reciprocal is negative 2 over root 3. Number 3. Theta is located in the second quadrant. I don't care about that yet. And tangent theta is negative 3. That I can work with. So the identity, the Pythagorean identity with tangent in it is the same one we just saw above. 1 plus tan squared is secant squared. In this case, tan is negative 3. It's getting squared, including that negative. 1 plus 9 is 10. Square root of both sides. Square root of 10. Don't forget the plus or minus. So now we need to think about whether it's the plus or the minus. So we're in the second quadrant. And we know the x, y, r definition of secant. Well, maybe you guys do actually. I always forget it. So I have to think, okay, wait a minute. Secant is related to cosine. I have memorized that cosine is x over r, so this one must be r over x. And honestly, I go through that every time I see one of these kind of minor trig functions. I have to think about what the corresponding one over here is. Okay, so it's r divided by x, and we are in the, which quadrant are we in here? Second quadrant. So thinking about an angle in the second quadrant, or in fact just any old point in the second quadrant, what can you say about the x and what can you say about the y? So the x is definitely a negative number. We went left from the origin, and the y is a positive number. Okay, so we'll have that there in the future. And so that means that when we did secant, we better get something negative. R is always a positive thing. We just assume that. So that means that in order to make, that means that this x right here had to have been negative. So that's a positive, that's a negative. Whole thing needs to be negative when all is said and done. So let's fill in our answer. Secant theta is therefore negative root 10. We'll copy down the given from the problem. Tangent theta is negative 3. We'll take care of the easy reciprocals right now. Negative 1/3 for cotan, negative 1 over root 10 for cosine. Okay, and still trying to figure out what the sine and cosecant are. Same game as before. We've established here that secant theta is negative root 10. I'm going to go ahead and force that to be a fraction. Okay, so it's negative root 10, that's fine. And then again, we said that that was the r divided by the x. And I realize after I write that neither of them is helpful to me because I'm looking for a y value, right? We know that sine is y divided by r. So ultimately we need something with y in it, and secant is not going to cut it. So I'll undo that. And let's go back to the tangent that's given to us. Tangent theta is definitely y over x, but it's also given as negative 3, which we'll go ahead and write as negative 3 over 1. Okay, so that helps me because I just needed to know the y and the r. So apparently the y is negative 3 and the x is 1. Let's not make the same mistake that I made up above. Does y equal negative 3 make sense for a random old point out here in the second quadrant? No, actually. We said that y was going to be something positive up there, and x was negative. So then it's kind of misleading to write it as negative 3 over 1. Maybe more honest would be 3 over negative 1. So still negative 3, but that negative kind of makes more sense going down there with the x. Super. So when we come up here and we want sine, we know that it's y divided by r. Y equals 3. That jives, so we'll put a 3 divided by. And then how much is the r value? Well, we actually have the r sitting in front of us in a couple of places. One place you can go is cosine theta, we know is x divided by r. X is negative 1. That agrees with what we said down here. So apparently r is positive root 10. So we'll put root 10 there. And once we have that, cosecant is easy. We just flip it over. Number 4. Theta is located in the first quadrant. Don't care. Cosine theta is 3x. We're going to use that. That's kind of unusual. There's x's in there instead of just a number. This kind of operation apparently is going to come up in calculus. So that must mean it's going to be harder than the other ones because there's a variable, but useful. So we'll start with our favorite Pythagorean identity that has cosine in it. We know that cosine is 3x. It's supposed to be squared the whole thing, including that 3. We'll subtract the 9x squared from both sides. Take the square root of both sides. Don't forget the plus or minus. Okay, so sine of theta is either root 1 minus 9x squared or negative root 1 minus 9x squared. Let's see if we can figure out which one it is. Okay, we are again in the first quadrant. So we pick a random point out here, call it x and y. What can we say about the signs, the signatures of x and y? Well, they're both positive because we're in the first quadrant. So it must be that we need to pick the plus sign here. So there you go. We've got our sine theta. It's positive root 1 minus 9x squared. Okay, we'll fill in cosine. That's given. That's easy. That's 3x. Let's go ahead and take care of the easy reciprocals. Okay, so what's left for us is tangent. If you ask me to find tangent and you tell me sine and cosine, and there's one and only one formula I'm going to use, and that's tangent is sine over cosine. Because those are exactly the two things we know. Root 1 minus 9x squared divided by 3x. So that's what goes here. And then the easy reciprocal over here. Okay, so that one seemed like it was going to be a little bit harder, and maybe it was because it had a variable floating in it instead of just being all numbers. But it wasn't too bad, and I think the reason it wasn't too bad was at the end, we were able to use that tangent theta is sine over cosine. So sometimes you got to be really crafty as a detective as you take the given information and find the values of the other 5 trig functions.